So we're going into section 7.4. We're going to be talking about cylinders, like I said. So we need to start off by talking about what makes something, what makes a shape a cylinder. So what do we think? What do we think is going to be important about cylinders? So the base, and how many bases does it have? Two bases, and where they're circular. A couple of other things that are important. Think back about what we decided about prisms. Prisms have two bases, right? Or two bases are polygons. What was important about the bases of prisms other than that they were polygons? They're congruent.
Yeah.
So we have two congruent. And there was one other thing that was important.
They're opposite each other.
What was it? They're opposite each other and they're parallel. So two congruent parallel bases. Parallel circular bases. So already the way that we're talking about a cylinder is similar to the way we talked about prisms. Yes. We have two congruent parallel circles as bases. The other thing is with prisms, our sides, our lateral faces were polygons. We just have, for a cylinder, we have a curved lateral face. And remember, lateral face is the same as a side. We're just talking about the side. So we can think of the side of a cylinder as just one curved surface. So let's draw a couple of pictures and label our parts. Cylinders are a little simpler than prisms because there are less parts to them. We don't have to keep track of it quite as much. So let's grab a cylinder here. There we go. So there's my cylinder. Shrink it down a little bit. So the circles are our bases. So we have a base, and this is a base. The segment here in the center that goes between the bases at a 90-degree angle is our altitude. And that's how we find our height. And this, I'll label that H, and this we'll label R. That's the radius of the base. And we just call it the radius. So these are really the only parts that we have to worry about on a cylinder. We have our altitude, where we find our height. We have our radius. And we have our two bases. Now we can have this cylinder because the altitude makes a 90-degree angle with the base. This would be a right cylinder. And it's this 90-degree angle that makes it a right cylinder. An oblique cylinder, if I sketch an oblique cylinder, if you want to sketch a cylinder, you can just make two oval shapes. And I'm going to make an oblique cylinder here and just connect the sides. See if I can connect those a little better. So there's an oblique cylinder. It's just tilted. If we connect the center of our two bases, we call that the axis. So on the right cylinder, the axis and the altitude are the same. On this cylinder, this that connects the center of the bases is the axis. And like we can do with parallelograms and triangles and trapezoids, on this cylinder, my altitude can be outside the cylinder. So this is an oblique cylinder. Again, oblique just means slanted. So our right cylinder here, our oblique cylinder here, our altitude we can find outside the cylinder. Any questions on our parts? All right, let's talk about our formulas. So we're going to have our surface area formula and our volume formula. So our surface area of a right cylinder so this formula only works for right cylinders. And the only things that we need for our formulas for a cylinder are the radius and the height. So R is the radius. And H is the height. Our surface area S equals 2 pi RH plus 2 pi R squared. And our units are square units. So we need these two things, radius of the base and the height, to find our surface area. Now let's look at why this formula looks the way it does. If I take this sheet of paper and I roll it up into a cylinder, like so. I'll do it this way, it's a little easier to see. If I roll it up into a cylinder, so my base is the open end. So I have one base on either side. The base is the open end. Now if I unroll the cylinder, I cut it down the side, and I unroll the cylinder, this side of this rectangle is the circumference of my base. That side of the rectangle is made up of the circumference of the base. That's the circumference of the circle. This side of the rectangle is just the height of the cylinder. So I have a rectangle here. So if I draw a net of this cylinder, the sides, if I unroll it, I get a rectangle. And this side of the rectangle is the circumference of the base, 2 pi r. This side of the rectangle is the height of the cylinder. So the area of the rectangle equals 2 pi r h. That's where this piece comes from. And then I also have the ends of my cylinder. If I draw my net here, these are the ends. And the radius of this is r. And that area is pi r squared. And we have another base that's exactly the same. So we have two of these circles with area pi r squared. So that's why the 2 pi, where the 2 pi r squared comes from. This is the area of this rectangle, and this is the area of the two circles that make up the bases. So that's why our formula looks like this. And this matches up exactly with the formula that we used for prisms. We could say that this is the height times the perimeter. Well, here the perimeter is just the perimeter of the base. The perimeter is just the circumference of the circle. So the height times the perimeter plus 2 times the area of the base. So it's exactly the same formula. We just have a little different way of calculating those things that are in the formula. Questions on that formula? We'll do a couple of examples at the end. All right, our volume formula. Volume of any cylinder. We don't have to have a right cylinder. This will work for any cylinder, and it's just like we talked about with prisms, where we made the stack of books and slanted them over and decided it had the same volume. So R is the radius of the base, and H is the height. Our volume is pi r squared times h, and we have units cubed. And again, this formula is exactly like the formula for a prism. Pi r squared is the area of the base, and h is the height. So we could write this as capital B times h, or the area of base times height. So it's the same, we have the same formulas for prisms and cylinders. So prisms and cylinders are kind of related. They're the same kind of shape. Just cylinders have curved sides, where prisms have polygons as sides. And cylinders are nice because we only need a couple of things to figure out their volume and their surface area. Any questions? All right, let's look at a couple of examples of using these formulas, and then we'll be done. So for this first one, we're going to use our surface area formula. We have a right cylinder. Our height is 2 feet. And the diameter of the base is 6 feet. We want to know the surface area. So we need two pieces of information. We need the height and we need the radius. So what is our radius here? Radius is going to be 3, half the diameter. And we'll plug into our formula. The surface area is 2 pi times r times h plus 2 pi r squared. And if I calculate that all out, I get, now with cylinders, we can calculate exact answers in terms of pi, like we did with circles. So this first quantity comes out to be 12 pi. And the second quantity comes out to be 18 pi. And that just equals 12 plus 18 is 30. So we get 30 pi square feet. If we want an approximate answer, we'd multiply 30 times pi, and we'd get this as approximately 94.25 square feet. So if our problem asks us for an exact answer, we just leave pi in our answer. If it asks us for an approximate answer, we multiply and round where it tells us to. Questions on using that formula? All right, let's do a volume calculation. We have a water tank. And our water tank is a cylinder. The height is 4 feet. and the diameter equals 14 feet. We want to know the volume. How much water does it hold? So for this formula, just like the last one, we need two pieces of information, the height and the radius. So what's our radius here? 7, half the diameter. So now we can plug into our formula. The volume is pi times r squared, 7 squared, times the height, times 4. If I multiply that out, I get 96.
You do 7 times 7, 49.
7 times 7 is 49,
And then
times 4.
is 196.
196 pi cubic feet. And if we want an approximate answer, we'd say that's approximately, and we'd multiply that out, 196 times pi. And we get about 615.44 cubic feet. Now, on your homework, in your homework problems, it's going to give you some problems where they give you, for example, does everyone have this? Anyone still need this up? Everyone good? Okay. So let me go back to the surface area formula. So they'll give you a problem where they give you the surface area and they give you the radius and they want you to figure out the height. When you get a problem like that, plug in the numbers that you have in your formula. So you would plug in your surface area here. You'd plug in your radius and calculate these out, and you'd have h, your height, sitting here. You don't know what it is. You just plug in your numbers for everything you have and solve for the part that you don't have. Get the part that you don't have by itself. So there'll be several problems in your homework where they ask you to find the height if you know the surface area and you know the radius. Or with the volume formula, they'll give you the volume and they'll give you the height and ask you to figure out the radius. So just plug in what you have in your formula and solve for the part that you don't have. Just like we've done in the past with other formulas that we've used. Plug in what you have, solve for what you don't have. There's several of those in your homework. All right, questions before we stop? Okay, homework for tonight. We're on page 456. Through 26 even, and then 28 through 32.